Question number 7. A pivoted uniform bar is under the action of the forces shown. The weight of the bar is 10 Newton. Draw the position of the weight on the figure. The position of the weight is at the center of mass of the uniform bar. For a uniform bar, its center of mass is right on the middle. So, this is the position of the weight. Remember, you have to draw this line starting from the middle of the uniform bar. Goes vertically downwards. And then put label on the arrow. Guys, you are not allowed to draw this line and the arrow on the top of the uniform bar, because it is said that the weight is on the center of mass of the uniform bar. So you have to draw it started from the center or the middle part of the uniform bar. Number 7b, the distance of the weight from the pivot. The position of the weight is right on the middle of the uniform bar. This means that the distance of the weight from both ends of the bar is 5 meters. The distance of the pivot from the left end is 6 meters. This one. So, the distance of the weight from the pivot is 1 meter, because 5 plus 1 equal to 6 meters. So that's the answer for number 7b, 1 meter. Number 7c, calculate the total clockwise moment. We have to go back to the figure to see which forces produce clockwise moment. The 15 Newton force and the 10 Newton force both will produce clockwise moment. Why? Because they both are on the right side of the pivot. Please remember, when a force is placed on the right side of the pivot, it will produce clockwise moment. The distance of the 15 Newton force from the pivot is 2 meters. The distance of the 10 Newton force from the pivot is 4 meters, not 2, yeah? Because 2 meters is only until here. You have to measure the distance from the position of the force until the position of the pivot. So the distance for the 10 Newton force is 4 meters, not 2 meters. So the answer for number 7c is 15 times 2 plus 10 times 4 equal to 30 plus 40. This equal to 70 Newton meter. Number 7d. Calculate the total anti-clockwise moment. Once again, we have to go back to the figure to know which forces produce the anti-clockwise moment. On the figure, we can see that weight and the 20 Newton force here both are on the left side of the pivot. When a force is placed on the left side of the pivot, it will produce anti-clockwise moment. So these two forces, the weight and the 20 Newton force, both will produce anti-clockwise moment. The weight of the uniform bar is known in the problem as 10 Newton, this one. The distance of the weight from the pivot is 1 meter, and the distance of the 20 Newton force from the pivot is 6 meters. So the answer for number 7D is 20 times 6 plus 10 times 1 equal to 120 plus 10 equal to 130 Newton meter.